Okay, so first lesson, points, lines, and planes. It seems very simplistic, and it is. The first word that we're going to learn is undefined terms. Undefined terms are the building blocks of geometry, which you wrote down, containing points, lines, and planes. So these are words that can't be defined, really, they can only be drawn. So if you think of like a point, a line, or a plane, and these make up all the other parts of geometry, whether it's shapes or angles, points, lines, and planes make everything up. So specifically, what is a point? It looks like this. It indicates a position or location. It has no shape or size. It's just a location, and we show it with a small dot. To name a point, we either say point A written out. You could abbreviate point A or draw it just point A. Also, in the honors classes, I noticed that students prefer if I just go through it quickly. If you ever want me to slow down, let me know. Line. Of course, you're familiar with a line. Looks like this. It goes on and on forever and ever. The technical definition, an infinite set of points that extend infinitely in two directions. It only has one dimension, and that dimension is length. And then there's an example right here of a line. Visual example. When we name a line, this might be new to you, you name it with 2 points on the line. So notice how there's 3 points on this line, but you only name it with 2 points. Any 2 points of your choice. So here's an example, line AB, or we could say that this is line BC or line AC. Just choose 2 points, and that's how you identify your line. Another way to name it is with this little lowercase letter right here. We could say that this is line M. Okay, the next word, you may have heard this word before, is plane. And a plane is a flat surface made up of points that extend in all directions. So I tend to think of like a piece of paper, but it's more than just this rectangle. It would go on and on forever. So imagine the paper like going on and on forever. It's like a flat surface. That is a plane. When you see it drawn on paper like this, you see a rectangle, but realistically, it goes on and on forever. So examples of planes, like visually, would be like the wall, the floor, maybe the whiteboard, just like a flat surface. It contains points, lines, and segments. It has two dimensions, length and width. When we name a plane, we name it with 3 points. So a line you name with 2 points, a plane you name with 3 points. It says non-collinear points. We'll get to what this word means in a second. But 3 points on this plane would be A, B, and C. So we'd say this is plane A, B, C. Sometimes they'll also have a little letter in the corner, and you can name the plane by that. So I know it's hard to see because of printing, but this is a R. So we could say that this is plane R. Okay, and the next box, these two words are probably new, collinear and coplanar. So collinear, even though that word's new, there is a part that you probably recognize, which is the word linear. Linear from algebra means straight line. So collinear points are points that fall in a straight line, like this. And the line doesn't have to be drawn for those points to be collinear. So collinear points are 3 or more points that lie on the same line. The opposite of collinear is non-collinear. So if points aren't in a straight line, they're non-collinear. Okay, so here is like a visual example. Collinear points here would be point A, B, C, and D. Those fall in a straight line. And then a non-collinear point would be point E. So collinear points here, A, B, C, and D. And then the non-collinear point is E. Okay, and the next word, coplanar, you could probably predict what this means. These are points that are on the same plane. So 4 more points that lie on the same plane are coplanar. The opposite would be non-coplanar. And it shows a visual example right here. So the points that are on the same plane would be D, C, A, and B. And then the non-coplanar point would be point E. So we have D, C, A, and B. The order of those points doesn't matter. And then the non-coplanar point would be point E. And I know it's kind of hard to make sense of on the paper, but what's happening is like you have a plane, like this piece of paper, D, C, A, and B are on the plane, and then E is like up here. It's like not on the same plane. So I know it's hard to see that on the paper, but that's what's happening. So like D, C, A, and B are on the paper, and then E is like up here. There's one more thing I want to add below here, and I'm going to explain this concept a little bit more in a second. It says any 2 points are collinear. So essentially 2 points make one line. And I'll explain what that means in a second. And it comes up in your homework a couple times too, so just write it down. And then any 3 points are coplanar. And they make one plane. Okay, so I'm going to explain what I mean by that. Marker. Okay, so any 2 points are going to be collinear. So if I was to draw a point here and like a random point here, these are collinear because I can draw a line through it. And it doesn't matter where I draw the points, I could draw them anywhere I want. Any 2 points are collinear because I can always draw a line through 2 points. We don't even have to think about it just in 2D space, we could think about it in 3D space. Like if I put a point right here and then I put a point on my desk, these points are collinear because I could draw a line through those points. So any 2 points, they're collinear. Or if you have 2 points, you have one line. And then with coplanar, any 3 points, you could draw a plane through. So I could draw any 3 points anywhere, and I could draw a plane through those 3 points. And no matter where I draw 3 points, I could draw a plane through those points. And again, it doesn't just have to be in 2D space. I could have 2 points on the board and 1 on the desk, and I could draw a plane through those 3 points. I could even have 1 on the floor, the desk, and the board, and you could draw a plane through those 3 points. So 3 points are always coplanar because we can draw a plane through them. And yeah. Okay, that comes up in a later chapter too, but it also comes up in this one, so we'll see that again. But for now, we're going to move over to the next page and we see a familiar word again. Okay, so the next word is intersection. You've definitely seen this, especially with intersecting lines. So here, it shows a line here, and they are intersecting. They're running into each other, and they intersect at a point. So 2 lines intersect at a point. And specifically, this is point O, which is kind of hard to see, but there's a little O in that intersection point. And then the next scenario, which you may not have seen before, is when a line intersects with a plane. So we have a plane here, flat surface, and then there is a line intersecting with that plane right here. And it goes like through the plane and down out the other side, like that. A line and a plane intersect at a point as well. And then the next one, 2 planes intersect at. It shows the 2 planes intersecting. It intersects right here. But remember, those planes go on forever and ever. So they intersect at a line, and that line goes on forever and ever. So 2 planes intersect at a line. Okay, so these are the building blocks, and these undefined terms make up everything else. So everything else are defined terms. So defined terms are terms that are defined using undefined terms. And or other defined terms. So example would be like an angle, maybe a segment, shapes, and so on. And then the last new word before we get into some practice is space. Obviously, that's not a new word for you guys. Space is exactly what you think of. Like, I think of outer space going on forever and ever. It includes everything, and it means the same thing in geometry too. So it's boundless, three-dimensional sets of points going in all directions. It contains everything. Lines, points, planes, see, lines, points, planes, shapes, prisms, which would be like 3D shapes, etc. Okay, so now we're going to move on to some practice using the vocabulary and just making sure we're solid with it. We have a few examples right down here at the bottom of the page and then a few on the back, but we're almost done actually. So here, it just gives us a task using the vocabulary we just saw. It says draw point Z, so we'll just draw point Z. Also, a little math hack is anytime you have Z, do the little line through it because Z looks a lot like a 2 and sometimes it can get confusing, so. Okay, the next one, it says draw 3 non-collinear points. So non-collinear points are points that are not in a straight line in a straight line. So when I make JKL, I just make sure I don't put them in a straight line. JKL. Okay, number 3, it says draw line JK. So JK are just 2 points that are on that line. So I can just draw a line and put points J and K on it. And for the next 2, it's exactly the same. So go ahead and do these 2 on your own. I'm going to freeze it and do it as well, and then we'll just compare answers. Okay. Here's what I got. Just make sure it matches. The order of the letters don't matter. So in this case, it doesn't matter. Okay, then the next one, it says draw plane S. So when we draw a plane, like show it visually, we just draw a rectangle or it looks like a parallelogram. I don't know. So there's our plane. And then to label our plane, we'll just put an S in the corner somewhere. It doesn't matter which corner, just put it in a corner. And then collinear points are in a straight line. So collinear points A, B, and C, we'll just draw them in a straight line. Remember, the line doesn't have to be drawn for them to be collinear. And then once you have that done, just flip to the back. Okay. Then we're going to do a couple examples together. For the first set of problems, I'll do like the first 2 with you and then have you like finish 3 through 7. It says name a point that is collinear with the given point. So collinear means that the points fall in a straight line. So for number 1, it says F and H. So I find that on the diagram over here, and it looks like the point that's collinear with that would be K. So we just put K. Then G and K right here, they fall in the same line, and then we have N would be collinear with that. Makes sense. So you try these. I will do it as well, and then we'll compare answers in a second. Okay. So you can compare answers. Sure you agree. If you don't agree, just let me know. Could have copied something wrong. Okay. The next set goes a little bit more in depth. It says decide whether the statements are true and false based on this diagram over here. So as we read these statements, we're just going to look at the diagram and determine whether they're true or false. So it says points A, B, and C are collinear. So I look for A, B, and C, A, B, and C, and they do not fall in a straight line. So this would be false. Then it says A, B, and C are coplanar. So that would be they fall on the same plane. And yes, A, B, and C does fall on the same plane, so that's true. Point F lies on line DE. Let's see, F does not lie on line DE, so that would be false. Line DE lies on plane DEF. Line DE on DEF. That is true. It says BD and DE intersect. Let's see. So line BD right here. And then DE, do they intersect? Yes, they do. So that is true. And then number 6, BD is the intersection of plane ABC and DEF. As far as I can tell, these planes don't intersect. If they intersected, they would intersect at a line. I don't know if that would be BD. Anyways, it looks like I have parallel planes. Parallel planes, that vocabulary comes up at some point, but they're planes that just go on and on forever, and they're parallel and they don't intersect. So as far as I can tell, no intersection, so this would be false. And down here, any questions so far? Pretty simple. Let it be easy. Not everything's easy. Enjoy being easy. For this part, we're not going to do this section. We're just going to do this here. It says name a point that is coplanar with the given point. So coplanar means they would be on the same plane. It says A, B, and C. So identify that in the picture A, B, and C. And that would be this plane. And the point coplanar to that would be point D. So that's what we're doing here. The next one, D, C, and F. Okay, cool. Well, that plane, the point coplanar would be point G. So you try this, try it. We'll compare answers in a second. So here's the answers I got. Do you have any questions? Okay, so from here, we're going to transition over to homework. But before we do that, I'm going to show you exactly what you're going to do or where to find the homework. So you're going to get a laptop, not quite yet, but in a second. You'll go into our Schoology course, and your homework is right here on the side, or if you go into week 1, it'll be under like Wednesday, it'll be right here. And then you'll click this. I need to enable it. I don't have it enabled yet. And then you'll click like start new attempt, and then it will give you the 10 questions. So you have 5 attempts to get your highest score. But once you get an 8 out of 10 or higher, I will consider that full credit. But there's just a variety of different question types. Based on the questions this morning, there's a couple ones that stand out that people wanted help with. This one, it says how many planes are shown in the figure. So just count how many surfaces this shape has, and that will give you the answer. What else? There's another one that was kind of tricky. It doesn't show it, but there's one that has this picture, but there's a different question, and it wants to know where the bottom plane and then this triangle intersect. Remember, planes intersect at a line. So the place it intersects is right here, and planes intersect at a line. So it'd be line BC is where this triangle and that plane intersect. So if you get that one, that's how you do it. Okay, so what you're going to do is you are going to get your numbered laptop and then bring it to your seat and log on to the homework. So try to do it kind of quickly.